Hello students, in this video lectures I am going to discuss inverse trigonometric function. So let us discuss first what is an invertible function. If f x to y is defined to be invertible, then if f is 1 1 and onto function, that is if f is a bijective, and conversely if f is 1 1 and onto, then f must be invertible. Suppose a function f x to y can be expressed as y equal to fx, then x can be expressed in terms of f inverse when f is invertible. So x can be written as x equal to f inverse y. Similarly, for trigonometric function, sine is a function from x to y, then y can be expressed in terms of sine x and x can be expressed in terms of sine inverse y. Here x is the domain of sine and y is the range of sine. In case of sine inverse, x is the range and y be the domain of inverse trigonometric function sine inverse. We have an example, sine pi by 6 equal to half. So pi by 6 can be written as sine inverse half. I hope you understood the definition of inverse trigonometric function. Now we have studied the in trigonometric function sin x, cos x, tan x, etc. can be used to find out an unknown side length of a right angle triangle if one side length and angles are known. And using the inverse trigonometric function sin inverse, cos inverse, tan inverse, we can find out an unknown measure of angle of a right angle triangle when two sides are known. So basically inverse trigonometric function is useful for finding an unknown angle of a right angle triangle when the two sides of the triangles are known. Here there is a table of domain and range of the trigonometric function. You can see in the table the domain of sine is r, real number, and its range is -1 to 1, and domain of cos is r and its range is -1 to 1. Domain of tan x is sin x by cos x. So cos x is 0 when x is an odd multiples of 90. So the domain of tan will be r minus x equal to twice n plus 1 by pi by 2 for all n belongs to z. That is the odd multiples of 90 and the range is r. Cot x is cos x by sin x. Sin x is 0 when x is an even multiple of 90. So r minus, so domain of cot will be r minus x such that x equal to n pi n belongs to z. This is the even multiple of 90 and the range of cot be r. Sec x is 1 by cos x. So cos x is 0 again when x is odd multiple. So that should not be there in the domain. So this should be subtracted from r. So r minus odd multiple of 90 and its range is r minus open bracket -1 to 1. Similarly cosec x 1 by sin x. Sin x is 0 when x is even multiple of 90. So r minus x has x equal to n pi n belongs to z and our range is r minus -1 to 1. I hope student you understood the domain and range of trigonometric function. Now I discuss about the domain and range of inverse trigonometric function. Since the domain of sine function is a set of all real numbers and range is the closed interval -1 to 1. If we restrict its domain to minus pi by 2 to pi by 2 and then it becomes 1 1 and onto with range -1 to 1. Actually this is the domain of the sine function and the domain of the sine function is real number and the real number is divided into many different intervals. Then all the different intervals are known as the different branches of sine inverse x. You can see minus 3 pi by 2 to minus pi by 2, minus pi by 2 to pi by 2, pi by 2 to 3 pi by 2, etc. All are the different branches. Here you can see in the diagram, here is the minus 3 pi by 2 to minus pi by 2, minus pi by 2 to pi by 2, pi by 2 to 3 pi by 2. All are different intervals, and these are the branches of sine inverse. And among these branches, one branch is known as the principal value branch, which is minus pi by 2 to pi by 2. This is known as principal value branch. On this branch, the principal value of sine inverse lies. So sine inverse function can be defined as sine inverse minus 1 to 1. It is a domain of sine inverse, and its range is closed bracket minus pi by 2 to pi by 2. I hope you understood, students, the principal value branch of sine inverse x. Similarly, we can find the principal value branch of other inverse trigonometric function, and using this, there is a table you can see in the chart. Sine inverse, its domain is minus 1 to 1 and range is minus pi by 2 to pi by 2. Cos inverse, domain is minus 1 to 1 and range is closed bracket 0 to pi. Tan inverse, domain is r and range is minus pi by 2 to pi by 2. Cot inverse, domain is r and range is open bracket 0 to pi. Sec inverse, domain is r minus open bracket minus 1 to 1 and range is closed bracket 0 to pi minus pi by 2. Cosec inverse, domain is r minus open bracket minus 1 to 1 and range is closed bracket minus pi by 2 to pi by 2 minus 0. All the principal value of inverse trigonometric function must lies between these intervals. So I hope, students, you understood the principal value branch table for inverse trigonometric function. There are some other points to be remembered in case of reciprocal angle. Sine inverse 1 by x can be written as cosec inverse x when x is greater than or equal to 1 or x is less than or equal to minus 1. We can prove it like this. First, let us say cosec inverse x equal to y. So x can be written as cosec y. So 1 by x is 1 by cosec y. So 1 by x equal to sine y. So sine inverse 1 by x equal to y. So sine inverse 1 by x equal to y. Y can be written as again cosec inverse x. So sine inverse 1 by x is nothing but cosec inverse x. Similarly, we can show that cos inverse 1 by x is sec inverse x when x is greater than or equal to 1, x is less than or equal to minus 1, and tan inverse 1 by x can be written as cot inverse x when x is greater than 0. In case of negative angles, sine inverse minus x can be written as minus of sine inverse x for all x belongs to closed interval minus 1 to 1. It can be proved like this. Let us take that sine inverse minus x equal to y. So minus x can be written as sine y. So x can be written as minus sine y, and this minus can be taken inside. So sine of minus y, again using the trigonometric function, inverse trigonometric function, sine inverse x equal to minus y. Putting the value of y, sine inverse minus x, you can show that sine inverse minus x equal to minus of sine inverse x. Using this, we can prove the other inverse trigonometric function in terms of negative angle. We can show that cos inverse minus x can be written as pi minus cos inverse x, and tan inverse minus x can be written minus of tan inverse x. Cot inverse minus x can be written pi minus cot inverse x. Sec inverse minus x, pi minus sec inverse x, and at last cosec inverse minus x can be written as minus of cosec inverse x. So students, I hope you understood this concept, and using this concept, let us do a few problems. First question is, find the principal value of cot inverse minus 1 by root 3. I'll show you the technique of finding the principal value of the given question. Let us take this value equal to y. So whenever this value equal to y, we can change the function cot y equal to minus 1 by root 3. And this can be written as minus of cot pi by 3. And it is can be written as cot of pi minus pi by 3, and it is cot of twice pi by 3. So the value of y we got twice pi by 3. Alright, now this value is cot, principal value of cot inverse minus of 1 by root 3 is nothing but y, which you got twice pi by 3. I hope you understood, students. Let us take another question. Find the principal value of cosec inverse minus of root 2. Let us take cosec inverse minus root 2 equal to x. So you can write cosec x equal to minus of root 2, which is nothing but minus of cosec pi by 4, and which can be written as cosec minus pi by 4, and the value of x equal to minus of pi by 4, which lies between closed interval minus pi by 2 minus 0, which is the principal value branch of cosec inverse, and its principal value must lies on that interval, hence its principal value is minus pi by 4. Another question you can see in the screen, that tan inverse sine of minus pi by 2. In this type of question, what do we have to do? Tan inverse sine minus pi by 2. First we keep this minus outside tan inverse. You can write sine inverse minus x is minus sine inverse x. So minus sine pi by 2. Sine pi by 2 is 1. So tan inverse minus x. Again you can keep minus outside tan inverse 1, which is minus pi by 4. One more question C, you can see in the screen. Find the value of the following. The sine inverse minus half plus 2 cos inverse minus root 3 by 2. Sine inverse, we can take minus of sine inverse half, first one, and plus 2 we can take outside, and cos inverse minus x you can write pi minus cos inverse x. So pi minus cos inverse root 3 by 2, and its value is sine inverse half is pi by 6 minus pi by 6 plus 2 is outside, pi minus it is pi by 6, and after simplification we got it 3 pi by 2, and this is how we can find the value of the given question. I hope, students, you understood the technique of finding the principal value of inverse trigonometric functions. Here I am giving you some assignment, some questions. All of you try yourself, and if you get any queries, any doubts, please contact me. I'll help you out. Thank you very much.